Okie doke. Welcome, everybody. As I was just saying, I think this is going to be fast and furious. I know before I get into the news, Chris, you were asking just a minute ago about the NEC and battery storage issues. And we've discussed this before, but it appears, I've heard this through different webinars, but I've not really, well, we haven't seen the text in the NEC, the 2020 NEC. But it looks like they're going to be requiring battery storage to be outdoors. And it doesn't make a lot of logical sense because, lead acid batteries outgas, but lithium ion don't. And of course, as we're going more and more to lithium ion, you would think battery technology was safer rather than more risky. But now they're going to require them to be outdoors. My guess is it's primarily to do with the voltage, the higher voltage levels of the batteries that are going to be inside buildings. So that's my guess. Although many people have pointed out that if you have a Tesla vehicle, you're going to park it in your garage. Yet if you've got a Tesla battery bank, you've got to put that outside because it's not safe to be in your garage. So who knows? That's probably something that people are going to argue about and mess with it. I think too, it's a lot of it is just that this stuff is written by people who live in Southern California and they just don't have any sense of climate issues that are around with battery storage. And I would think security is a huge issue too, with putting these things outdoors. We're going to have a lot of people walking off with this stuff. So I don't know. I suspect that's a rule that will be in flux.
Well, Jay, I think the other thing that doesn't make, to pile on, that doesn't make any sense whatsoever is if you have an electric vehicle, you have a 60 plus kilowatt hour battery pack in your effing garage.
Yeah. Yep. But you couldn't put the same battery on the wall in the garage because that's
much smaller, much smaller battery.
Right. Well, we'll see where that evolves to.
Is that official, Jay? I know last time when we were down in Cincinnati, that was like talked about. Is that official yet or no?
Nothing's official until the code is actually adopted. Okay. I've only heard it discussed in webinars, but I've looked for some of the verbiage. I'm looking for a specific reference where it says in section whatever this is being said, and I haven't seen that anywhere in print or anything. So we're right now just through I think the first draft is written. It's in the comment phase of the second draft. So who knows? There's time to evolve it. I'm not going to have any direct impact on that one way or the other. So I'll be a passive observer, just like most things in this world. Okay, let me hit, there's not a whole lot of news. And then as soon as I hit the news, I'll ask if anybody else has anything else. And then I've got an item I thought we'd maybe discuss. I did a little research on the difference between AC coupled and DC coupled and the advantages and disadvantages of both. And so we'll touch on that real quick. Okay, so I found there's a new company, there's a company called Mitrix that is starting to market solar panels that that blend in with different styles of roof. So that's one of those, they have an image of different kinds of shingles on it or slate. So you can pick your solar panel that matches the imagery of your roof, which seems to me a lot better solution than one of these Tesla solar roof things. If you're just talking about aesthetics, it gets installed and put in the same way as any other panel. It just sort of is camouflaged. So that makes a lot of sense. Biden just signed it's basically the anti-slave legislation that's targeting Xinjiang, China, Xinjiang, the Uyghurs, apparently using slave labor for producing things. So how that affects solar, not so much. I suspect it's one of those things where instead of saying it's made there, they'll say it's made somewhere else in China. It's like saying we're not going to import anything from Texas. So you move your operations to Oklahoma and do exactly the same thing that you were going to do. So that is one of those symbolic things more than substantial. In your neck of the woods there, Bob, I know you're down in Florida, but Illinois got $350 million more to incentivize solar. They've reinstituted their adjustable block program, which ran out in the third quarter of 2021, the money did. So supposedly as of December 14th, that's back on track. And my understanding, you may know more on that, that it basically prepays the first 15 years of RECs. Is that right? Yep.
Yeah, it does. But understand that they started a list in 2020 or end of 2020, and it is full. So this money could probably mostly gone by now, because first come, first serve, and you cannot believe how many of the installers put their money out that this program would come through, and gave discount to their customers through 2021. But now with this, they're not going to be bankrupt, because they would have been.
Yeah. Well, it's like any other government program. I wanted to find out a little bit more about it. So I downloaded their explanation of the adjustable block program. And it was a 70-page document explaining how this thing works. And after the first page, I was like, yeah, okay, I'm glad I don't live in Illinois, because I don't think I could understand it. But I remember back when Ohio had these incentive programs, and it was like what you're saying, Bob. The money would come available on December 1st, and by December 1st at 12:05, the money was used up, because everybody with the inside contacts were already, had allocated it. So I suspect 350 million sounds like a lot, but I suspect that goes pretty quick.
Well, you can expect a check on a 10 kilowatt system for at least $11,500 to the customer.
Really? Well, shoot, that's got to be 10 kilowatt. Well, that's a third of the project at least. The third of the project cost.
So how many $11,000 checks can they write to get the 35 million?
Yeah, and I know that their formula was like different sized projects. So some of them have to be commercial, some have to be community solar, some have to be mid-range, some have to be residential. So yeah, you get a couple of megawatt program in there, and it's going to chew up, in the millions rather than in the thousands. Okay, did anybody have a question before I jump into the AC versus DC? Yeah, Bill, you've got something?
So let me finish.
Okay.
So on residential, to use up to 350 million, you have to do 3,050 installs. That money's already gone.
Yeah, not very many. Okay, Bill, you had something?
Yeah, I watched the link with Enphase and their battery system. I have an opportunity to go witness the installation of one of those. And I was wondering, I sort of maybe re-listened to last week's discussion, but could you summarize the concerns that y'all had with the system as outlined in that video or that webinar that you gave us a link to?
Oh, you mean the Enphase AC coupled system?
I think so, yeah.
Yeah, it sounds like with their IQ8 series, they actually address some of the concerns that we had with AC coupled. And it has to do with battery sizing versus array sizing, and the matching in size of your inverter that's attached to your solar array versus the inverter that's attached to the battery bank. And the IQ8 says, okay, our inverters are now smart enough that that's no longer an issue. So you can have a very large solar array with a very small battery without it being overpowered, because these things essentially have charge controllers built into them, you know, at the, or the ability to control the charge. One thing that they did mention in that webinar that I remember is that they're basically now saying there are 3 families of N-phase inverters, microinverters. There's the IQ8 family, there's the IQ 6 and 7s, and then there's the M215s and the M250s. And these are not necessarily intercompatible when you talk about the different functionality. If you're doing just a straight grid tied system, yeah, they're all interchangeable. You can put IQ8s in with M215s, no problem. Each one works independently. But when you start looking at battery backup, then the M215s and the M250s will not necessarily work with their battery-based inverters, because I suspect they're using the IQ8s in their inverters. And then there's if you're doing it without battery, but you can use the array in the sunshine, you know, so that's one of the features of the new IQ8. They're saying this thing's smart enough that it will sense when the grid goes down and can still operate in island mode or in standalone mode, even if there are no batteries. Obviously, you'll get a fluctuating output, so you got to do some load management. But the IQ6s and the IQ7s will not function in that mode. So there's some now interoperability concerns that makes things a little more complicated. Was that
I'll
your
listen to it
impression?
again. Well, you know, I'm a little slow on the uptake here. I'll re-listen to that video. Not only that, I think he mentioned that there's another 3-hour training. I'll do both. Yeah.
Yeah,
That's got
they're
it.
also, they have a certification too, and I was going to go through that maybe over the holidays, where you can go into Enphase and you can become certified as an installer for Enphase. Solar Edge has a similar thing, so I just thought it would be good for my own knowledge to go through those things online. There's no cost associated with them, so you can begin to get a sense of what are the advantages and disadvantages.
Okay.
So.
Jay, it's
Good.
Bruce. Speaking of certification, I was reading about a panel. You have to be certified to get the warranty. Is that commonplace for a panel?
I'm not aware of that for specific panel manufacturing. You mean you've got to, like it would be a Canadian solar panel and you've got to be a certified Canadian solar installer in order for the warranty to be good?
It was the company, whatever. I don't remember which company.
Yeah, I don't know why that would be an issue. Panels aren't that unique, you know, they're just hunks of silicon. But has anybody else heard of any manufacturers requiring for solar panels? I know inverters and things like that you might have, but
The city of Houston has a list, NERDL list, nationally recognized testing laboratories, and they won't allow certain panels or panels that don't have, not on that list, to be used, which is, I think it's insane, but it is what it is.
yeah. Well,
Well,
they're probably going with the UL 1703 certification. If it hasn't been UL tested, they don't want to have them installed.
as you said, anybody can install solar panels in Illinois. There is no requirement.
Yeah, I think he's talking about specific manufacturers of panels saying that their warranty is only valid if it's installed by one of their trained people, which,
Well, I had it so that I can't remember the name of the manufacturer. It's Canadian manufacturer, because I was ICC certified, they did extend the warranty on there from 30 years to 35 years.
Oh, well, that I could see, you know, if they're wanting to give a bonus on it, but if they're dinging you because, you know, that seems weird. I don't disbelieve it. It just seems weird. So, all right. Well, I wanted to touch on the AC coupled versus DC coupling because my understanding, you know, as these things became a thing, you're always hearing it expressed as DC coupling is a little bit more efficient than AC coupling, and typically you'll do AC coupling for existing systems because it's easier to retrofit these existing systems. So just as a little refresher, with AC coupling, you've got, for instance, an existing system or a microinverter where from the panel, you're getting AC power. So that AC power already exists with no battery backup, whether it's an existing grid-tied string inverter or whether it's a microinverter. Then you want to use battery backup. So you've got to now have a battery-based inverter charger that will take that AC power, convert it to DC power, and place it back into the battery bank. Then you've got to take that DC power and through that inverter charger, convert it to AC power once again in order to use it in your loads. So there's a triple conversion process going on. DC in the solar panel to AC, then AC to DC to the battery, and then from the battery to the load, DC to AC. So that seems quite inefficient, and it is. In fact, the best you could hope for is about a 90% efficiency rate after going through all of these different couplings. DC just, of course, takes DC, puts it directly into the battery with the help of a charge controller typically, and then takes that DC battery power, converts it to AC and uses it on the load. So from a logic standpoint, makes a lot of sense. But you typically have to do that in the initial design. Otherwise, you've got to take your inverter and replace it with an inverter, with a multi-mode inverter if you don't already have one, because it has to have the ability to operate in standalone mode as well as grid-tied mode. And many of the inverters don't do that unless obviously they're designed to. Yeah, Bob, you had a question?
So you're talking on DC systems that are basically off-grid systems, right?
They are when the grid goes down. So there's a transfer switch, disconnects from the grid, and then typically directs power to a critical load panel, although it could be the whole house if the battery system is big enough.
But if you're a grid-tied system, you're going to be AC no matter what.
Well, after the inverter, yeah, for sure. And I mean, you are even if you're a standalone. So basically the multi-mode inverter has to be able to sense when the grid goes off, have a transfer switch that disconnects from the main connection point to the grid, and then redirects auxiliary power to, you know, a critical load panel. That's typically, so you usually have two service panels, one that's connected to the grid, and then a second one that's connected to critical loads. And when the grid is operational, everything's connected together. So everything's being serviced. But when the grid goes down, a transfer switch disconnects from the main panel and you're operating in a standalone mode. So that's a typical DC system, a DC coupled system. AC coupled works exactly the same way. It's just that you're going through a couple of steps before you get there. There's a couple of reasons why AC coupled systems are becoming more and more popular. Is because at the residential level, the two main suppliers that people use are going to be SolarEdge and Enphase, the microinverters or the power optimizers. And SolarEdge has had a lot of reliability problems. So people are going, excuse me, to Enphase increasingly, which means you've got to have an AC coupled system. So Enphase has come out with their AC coupled system that's sort of a proprietary thing, and it's being sold all as one package. So there's a lot of people who are saying, okay, the reliability, the cost, the efficiency isn't that big of a deal. So I'm going to go with that. Solar Edge losing a little bit of market share because their inverters keep crashing a bit. And that might be caused by some of these other issues I identified. In fact, well, I'll run through them real quick because that's the way it's typically sold in articles. Is DC coupled is the way to go if you're designing your system from scratch. AC coupled is the way to go if you've got to retrofit an existing system. So, all right, very simplistic there. But one of the issues, and we touched on last time, was with AC coupled, you've got a battery or you've got an inverter to inverter ratio issue, because you've got basically an inverter that's connected to your solar array, and you've got an inverter that's connected to your batteries. And the inverter that's connected to the batteries has to be at least as big as the inverter that's connected to your solar array. In fact, they recommend it be at least 125% the size. Otherwise, let's say you've got a smaller inverter on your batteries, the grid goes down. Now all your power is being directed towards that inverter from your solar array, and you can cook your smaller inverter. So the secondary inverter has to be as big or bigger. Then you've got to have an issue where the battery bank size is based on the size of the inverter that it is connected to. Because otherwise, let's say that you don't have much load, the grid is down and the batteries are full, where is the power output going to go that's coming in from the array? Because now we're in AC mode and it's got to go somewhere. And so you can either turn off your inverter, which is an option, or have a load dump of some sort, you know, just a big bank of resistors or something where you're dumping off this load. So, and then the other issue is the way AC coupled inverters work is without this charge controlling system that's usually involved in a DC system, the batteries just get whatever's left over, you know, and so they get a lot or they get a little, depending on the load, depending on how much sunlight there is, things like that. So if they're getting a lot, the batteries could be charging at a rate faster than is healthy for the batteries. They're basically getting overpowered. They always say a charge rate of C5 is about as fast as you want to go, or C6 in there. So basically from empty to full over a period of 5 or 6 hours is what, but if you're charging it, say a C1 where you're filling it up in 1 hour, you're going to damage the battery. And there's nothing in the system that's controlling that other than the size of the battery bank versus the size of the array. There is also an issue of, let's say that you deplete down your batteries to 100% and the battery bank is dead and the inverter that's connected to it shuts off, right? Well, that battery bank is sending a false signal to your grid-tied inverter telling it the grid is functioning. Well, that signal is now lost and cannot be recaptured because there's no way that these batteries can generate enough power to send that signal. So your system's just shut off. Even if the grid is still down, it's shut off. Conversely, let's say that it gets too much power coming in and the battery-based inverter has to shut down to protect itself. Same thing happens. No false signal is being sent to the grid-tied inverters connected to the solar array. So their anti-islanding mode will kick in and they'll shut down. So then unless your battery-based inverter has a way of restarting itself, it would have to be manually turned back on and rebooted. So those are an issue. Another issue is, let's say you've got an inverter that's hooked up to this system if too much power is coming in, you can actually backfeed your inverter with power, or your generator with power, and fry your generator. So there's a lot of issues when things are undersized, when the battery bank or the inverter is, or there is no load dump. I would think a load dump would make a lot of sense, you know, in a situation like that. With the DC, you do incorporate a charge controller, so a lot of these things just go away. If the solar array is generating too much power, the charge controller just, you know, cuts it off. If your batteries are charging at a certain rate that's comfortable, the charge controller will taper that input. Now, those are some of the reasons why you might choose a DC system, DC coupled over AC coupled. Some of the reasons why you might choose an AC coupled versus DC coupled is that in the installation of this, if you find you're essentially having to connect both DC inputs to two different bus bars, essentially within the charger. If you think about it, the way that these things operate, they're operating at a maximum power point fluctuation as the array is receiving more sunlight, temperature changes, things like that. The MPPT changes based on that. But if I've got a battery connected to that, then that's going to disrupt the signal to the MPPT, because now I have a constant state of charge voltage coming in as opposed to a voltage that's varying. So that's going to mess that up. You can also redirect more power back to the generator if you've got a generator there, unless these things are isolated. So essentially, these bimodal inverters are what they call multi-stage or multi-ported inverters, which means that the powers have to be coming in from different positions and have to be processed in isolation with each other, which, according to what I read, causes for greater inefficiencies, more stress on the system, and greater potential of failure within that inverter, which is what we're seeing with the Solar Edge inverters. And that may be part of the cost, you know, part of the reason for that is you're starting to see these, the greater stress placed on that system. So that's when you're getting into the issue of manufacturing. Now, one of the things that the AC coupled systems will do, you remember I said that if you're getting too much power, you can either turn off your inverter that's feeding the battery-based inverter, or have a load dump. Well, rather than having somebody physically have to turn on and off a switch, which is not very efficient of people's time, and nobody's going to do it, but they do a thing they call frequency shifting, which I've vaguely seen this before, and it's really hard to find information, at least it was for me, on what the heck they mean by frequency shifting, because they say they can control the output of the grid-tied inverter through frequency shifting. Well, we know frequency in the United States is going to be 60 hertz, right? That's the frequency of the signal. And my understanding of it, and I'm happy to be corrected if I'm wrong, is you remember when we study like the IV curve? The IV curve, you get different power outputs based on the relative relationship between amps and volts. So you're getting that in the IV curve. Well, there seems to be a similar curve with frequency. And as you increase the frequency of the system, the power output decreases and falls off pretty radically. So what we found is if you increase the frequency by 2 hertz, it will basically cut production to 0 from the inverter. if you increase it by half a hertz, you know, it'll decrease it down to about, I don't know, say 90%. And that between there and that too, you can move the frequency and curtail some of the output from the inverter. So that's what they do. As they're sensing the amount of power that's required, they adjust the output frequency in the battery-based inverter that's going to load. And of course, the grid-tied inverter has to match the frequency, at which point power output is diminished. So that led me to think, well, okay, what does that do to the loads? If you start messing with the frequency, how much frequency tolerance is there in the loads that are being serviced? And apparently within the grid, they figure half a hertz, yeah, is okay in that range between 59.5 and 60.5. They just assume you're operating within normal limitation. But they're really saying that anything more than 1 hertz is considered outside of tolerance range. And it did see in the article, they were saying that 61.8 hertz, anything above that will actually damage generators that are attached to it. So I assume there are certain loads that are more sensitive than others. So obviously when you're starting to get to 61.8, you're almost to that too, where nothing's being produced. So my guess is through this frequency shifting, they're able to lower the output from the original inverter, but it may or may not cause damage on sensitive electronic devices. I would guess is something I would look at. So that's my sense of AC coupled versus DC coupled, advantages and disadvantages to both, but the whole idea of frequency shifting and the way batteries charge and the way they don't charge, I think we're going to get a lot more into that as more and more people are getting involved in these coupled systems, because this was always just kind of a 5% of installs that incorporated batteries, but now we're getting up into the 40% range where people are using batteries more and more. So any comments about that? I hope.
Yeah, Jay, to be clear, Jay, now does that generator, does it have to be running? I guess.
I would think, but I'm not sure about that, because obviously if you're overproducing power at the array, you're hopefully not going to be running your generator as well. So I don't know. I thought about that when I was reading that, Bruce, but logically it would seem that it'd have to be running. You know, you would think there would be fail safes protecting it if it's not turned on. So, yeah, Bob.
Yeah, generally speaking, when you have transformers involved, you're going to lose efficiency in going from one stage to another. But today they're doing solid state, so the efficiencies are going to be a lot higher than using those type of systems, and they'll last a lot longer than 10 years too.
Yeah, well, in the old days when you had 90% efficient inverters that were transformer based, doing a three-time conversion, you'd lose 70%. It just wasn't practical. But now that they're up in the 99, 98% efficient, yeah, I mean, AC coupled is a viable option, but I think you're starting to see that there are some other issues. Another issue that they kept talking about was, you know, with the AC coupled system is that if you're generating a false grid signal, whenever that false grid signal is lost by the microinverter or the grid-tied inverter, there's a 5-minute reboot process, you know, every time you lose that signal. So you may find that generation is really disrupted, even if you just get a momentary flash of a loss of a signal coming from your battery-based inverter. That's going to result in a 5-minute outage as the original inverter begins to reconnect itself. So that could be very frustrating.
So You said that too much charging can hurt a battery. Now, my automotive knowledge of battery charging is basically that you can put any voltage on there. It's a chemical. Battery is chemical. It's not electromechanical. And it's just going to do what it's going to do. So I cannot wrap my head around overcharging. If you put 1,000 amps into a 36 amp battery, is this what you're talking about?
Yeah, yeah. If you're dumping power into a battery that it's not capable of, or it's being charged too quickly, then it tends to wear down the battery. Probably the same as too deep a depth of discharge will eventually wear down the battery. It's not something that's going to fry it immediately. Although if you're getting too much amps coming into your microinverter or into your battery-based inverter, it's going to fry that inverter or shut it off. So that's going to be an issue. But it seems to me there's an easy fix to all of this, is to put a charge controller between the inverter and the battery. You know, I mean, problem solved at that point. You know, although maybe not, because you still have AC power coming from the inverter and it's got to go somewhere.
But you're basically talking lead acid batteries here, right?
No, I think most of these are going to be lithium ion, but lead acid, same thing. I think the same issues apply, that you may cause damage to the battery by overcharging it. But I think because, and you guys, somebody may know more about this than I do know with wind turbines, because they generate AC power, that AC power has to go somewhere once it's been generated. With DC power from a solar array, there is not that same issue. If there's no load, it simply does not go anywhere. It may have to do, it seems to me, just as I'm saying this, remember there being a discussion about the backward and forward motion of AC waveforms, that if the power can't go forward, then it tends to, you know, want to back up on itself. And begins to affect the source. I might have that completely wrong, but I don't know. Bill, you're an engineer of sorts. Do you know any of the, is it just simply correct to assume that once AC power is generated, it must be utilized in some form or fashion? And that DC power doesn't have that same constraint? Do you know? You're still on mute, Bill.
No, I don't have any comments. I mean, I suppose you think about, I don't know. I can't connect to it. I'm sorry.
Okay. All right. Well, this is going to be a thing for more. I know within the grid, because obviously the grid generates AC power, and all of it can't be used. I mean, you know, there's going to be some fluctuation. You can't just assume you got it 100% right. But what happens within the large system like that is that voltage tends to increase and decrease within a certain range. If you've got too much power on the grid, then the voltage will increase, like water pressure. And if you've got too little, then it'll decrease, again, like water pressure. But it has enough flexibility within that a plus or minus 5% you can deal with.
Well, you understand frequency is also an indicator, and I think I've heard more batteries respond to, you know, instantaneously to frequency sags or over, although I don't know. Yeah, you know, that's it's actually remarkable that we do have reasonably reliable power most of the time.
Yeah.
You know, I mean, that there are systems in place to regulate. I mean, you know, you can't store electrons, right? Except now we're beginning to do that with batteries. But, you know, it's amazing that every 15 minutes, ERCOT, for example, dispatches power, turn it on, turn it off, And I guess it's because the grid has such an inertia, right? That the effects of changing load are manageable on a time scale of 15 minutes.
Yeah, I think it's that 10% plus or minus on the voltage and the sheer size that gives them that flexibility, plus pretty good predictive models. Jay, you had a comment there?
Just, it'd be silly to waste it, but how much current over time and how much instantaneous can a properly designed ground dissipate into the earth?
Yeah, I don't know. Of course, most of the time your systems are designed that if they sense power on the ground, you're going to be shutting down as a ground fault. So I don't know that that would be a good load dump. You could just hook up resistors and let that just sort of cook out into the air. I've seen that like on the wind turbine I mentioned before, where you just have a wall of resistors where it's just heating up the air as opposed to sending it into the ground. Because once you're in your grounding system, then all those ground fault sensors are going to go off and your production is going to shut off.
Because you're essentially feeding power into the wrong end of the ground fault.
Well, they're designed, if power is on the grounding system, that's an indication that something is wrong, that there is a fault, that there's a short circuit somewhere in your system, or an outside power source coming in. So to protect everything and everybody, in the case of solar, your inverter is just going to shut off. And it's going to give you an indicator and say, until you've corrected where this ground fault is coming from, this system will not operate. So if you're saying, okay, we're going to dissipate the power through the grounding system, well, then that's going to trip the alarms, and the rest of the system will just shut off. So, yeah, Bob?
I'm going way back in my early education, but I remember a rule that you don't run generators open, that they'll just destroy themselves if you have no load on a generator. Now, moving that, most of the grid is generator produced.
Yeah.
And so now you have variable loads hitting the grid at all times. So it just has to be within a certain range, I'm sure.
Yeah. Yeah, the grid, as Bill was pointing out, is a pretty remarkable thing, and of course the ability of them to predict global usage, within the larger system. And that's one of the problems ERCOT has down there in Texas, is because they are not interconnected seamlessly with the rest of the world. They've got a smaller, more isolated unit that makes things harder to predict. Because you can't predict the behavior of a single individual, but you can predict the behavior of a population. So that X number of kilowatt hours are going to be required at any particular moment within a fairly predictable range, but you don't know that J is going to turn on a light switch. That's just something you cannot predict. So the bigger the system, the easier it is to work within as far as predictability. But like I can predict that the next election will be within 2 or 3 percentage points either way. But I have no idea how any individual is going to vote. Yeah, Bill?
I was just reminded, frequently we find ourselves on the freeway in stop and go traffic. And I once saw a mathematical analysis of that, and it's, you can mathematically analyze that. If you saw this stop and go from the air, it's kind of like a sine wave propagating backwards, right? And to the extent that everybody behaves the same, it's more mathematical. To the extent that someone breaks the rule, namely, I generally maintain a fairly large distance between me and the next car, so I interrupt that sine wave totally, right? This is the magic of people behaving the same versus an outlier. And
Yep, except I can predict that somebody's gonna go past you and pull into that space between you and the other car, you know, and then slam their brakes on. So that's highly predictable, right? So, all right, any other questions on today's activity? Yeah, Bob? You're muted, Bob.
I just one question. When do we start the Christmas caroling like we did last?
That must have been why you were muted. So, all right, well, I'll go on mute and then we'll start singing. So, all right, okay, well, great. And speaking of Christmas, everybody have a nice Christmas and I'll see you next Tuesday.
You too.
All right, take
Bye.
care. Bye-bye.
Thank you.